my session, Build Your First Full Stack Blazor App. I'm Ed Charbeneau. I'm a senior developer advocate or principal developer advocate for Progress Software. I primarily focus on Blazor in the Telerik UI for Blazor. So I'm a writer, speaker, podcaster. I do Twitch TV live streams as well. But if you ever want to reach out, just ping me on Twitter. I go by my name everywhere. I should be pretty easy to find. I have a fairly unique last name. We also have a free ebook up on our website. I'll share a link to that at the end as well. Just for a quick reference here, how many of you out there are .NET developers or have done .NET development at some point in your career? Okay. The rest of you folks, I'm assuming, are interested in .NET in some way, shape, or form. We're going to be talking a bit about .NET today and what exactly Blazor is and how it can help you. .NET developers, we have a unique skill set to the .NET ecosystem. And over the years, we've had several ways of creating web applications with web forms and MVC, and things have changed over time. There's a lot of popular front-end frameworks out there right now, like React and Vue and Angular, and all of those things use JavaScript. So that means we have to take our existing skills with .NET and C# in that ecosystem and then translate those over to something new in JavaScript. So with Blazor, I'm going to show you how you can write full stack applications, even the client side of your application, using just .NET technology, and you no longer have to rely on learning JavaScript or using any of those JavaScript libraries out there. What's nice about this is not having to use JavaScript or even very little of it, is it lowers the learning curve to what you need to do to get on a new web front-end framework. And this leads to really high productivity. There's a lot of real highly productive things that you can do with the Blazor framework. So what exactly is Blazor? This is a combination of the .NET framework and running it in the browser with the Razor engine. So Razor plus browser comes out to Blazor, and this is our brand new framework. I'd like to go over a little bit of things that Blazor is and Blazor isn't, because it kind of clears things up with a lot of different frameworks we've had in the .NET space in the past. So one thing that we can really focus on is this is .NET in the client. So this is client-side C# and the .NET framework running in the browser. It uses all web standard technologies. So this isn't something like Silverlight all over again. This is all web standard tech, which is one of the things that makes Blazor great. One of those web standard technologies that we'll be talking about today is WebAssembly. WebAssembly is quite amazing. I'll get into some of the details of how it operates with Blazor and some of the new features that came in .NET 6 that even expand the WebAssembly libraries even further. And this is standard .NET libraries. So we're not doing anything crazy with our .NET assemblies. We're actually just running standard DLLs in the browser. So again, it's not a plugin. This isn't Silverlight again. It's not anything that your clients need to know about. It's all technology that is supported by web standards. There are some similarities to web forms just because this is .NET, and you'll see code patterns and things that might seem familiar, but the implementation of Blazor is nothing like web forms. There's no view state. None of those old school things exist in Blazor. This is all brand new, written from the ground up stuff. And again, .NET standard libraries. So we're not transpiling here. This isn't TypeScript in any way, shape, or form. We're not taking your C# and turning it into JavaScript. The browser is actually able to process your C# and your .NET code right there in the browser. And I'll explain how exactly all that works. If you're coming from a JavaScript background or you use JavaScript tools, Angular and React and Vue, you might be asking, like, why would I want to use something like Blazor? The key differences are, what are you going to be doing with it, and what are your current skill sets? So for me, I've been a .NET developer my whole career for over 20 years now. I know JavaScript very well, but I feel much more comfortable with .NET. It's something that I've always worked with and had great productivity with. So I can rely on .NET standard libraries, NuGet packages, things that I've used for years without issue. I've also had very good luck with the MS Build system. It's very reliable, it's easy to run. You open Visual Studio, you can even just hit play and your app just works. There's not a lot of configuration involved with MS Build. And C# is a wonderful language. It's strongly typed. It's very secure, and it just writes very well. I really enjoy working with C# and strongly typed languages. With those other frameworks, you have to rely on things like NPM. For me, this was problematic. I won't go into it all in this short talk, but I've had issues in my career where NPM has failed me. Webpack can be quite clunky to operate as well. It's gotten a lot better over the years. They've made great improvements, but for quite some time, it's been a little bit difficult to use. And then TypeScript is wonderful. JavaScript is too, but I like something that was written from the ground up to be a strongly typed language rather than something that's dynamic like JavaScript. So it's a matter of preference. If you want to boil it down to a simple word, it's really a matter of preference. And for me, I prefer the .NET ecosystem. So Blazor itself has a ton of features. It's a rather new framework if you look at the context of Angular and React. Blazor is kind of the baby of the crowd, but it has a lot of advanced features for being developed in such a short period of time. It is based on .NET, so it has a lot of things that .NET already has. So dependency injection is going to be identical on the front end of your application, just as it would with any other .NET app. So .NET, Xamarin, Maui, all of those things, console apps, all share the same dependency injection behaviors. So .NET has that, or Blazor has that as well. It has a really rich component model. I'll show you how to build a couple components today. The component model is awfully similar to React. Has a little bit of an Angular feel too, but it's a little bit closer to React than any of the other front-end systems that you might be using. It's extremely easy to use. One of the best things about Blazor is just how easy components are to create, and everything inside of Blazor is component-based. We have debugging in Blazor as well. You can set breakpoints in your C# code, hit those from within the browser. It's a pretty seamless operation to do debugging in Blazor. So just because it's running in WebAssembly and you have this .NET context there, you're not held back at all on debugging. There's client-side routing involved with Blazor. So if you're looking at things like Angular and React, they have client-side routing. Blazor has that as well. It's done slightly different as far as marking those things up and the semantics around it, but there is very robust client-side routing. You can set query parameters and pass values around, do all those things very easily with routing. One thing that .NET developers really love to do is unit test. We're testaholics in .NET. We test our code with XUnit and all sorts of other tooling. There's actually a library dedicated to Blazor in unit testing your components. You don't even have to open a browser, run your app or anything. You can write a component, unit test that component, and get a validation whether that unit test passed or not. If you're familiar with tree shaking in JavaScript, we have that too. It's called assembly trimming. This comes from the Xamarin world. Like, this isn't new tech that's been around just a few years. This has been around for about a decade with the Xamarin technology. So this tree shaking or assembly trimming happens when you create APKs for a Xamarin project. That technology has been adopted for Blazor, so you can minimize the amount of code that you're sending down to your clients. Server-side rendering is something that's quite difficult in some of those JavaScript libraries. One thing that's great about Blazor is if you're running a .NET server, you can pre-render your application before it's sent to the client. So it's very responsive. There's a couple ways to do that. We'll talk about what those are. Forms and validation is just absolutely simple. If you've ever used the data annotation attributes in .NET before, then you already know how to do validation in Blazor. It's the same thing. Hot reloading is something that just came in .NET 6, which is shipping this week. It literally came out Monday, Monday. Monday it finally shipped. So we have hot reload in Blazor as well. You'll see some of that today. And then if you have libraries that already exist in the JavaScript ecosystem, you can still use those as well. So if there's something that you really rely on in the JavaScript, say you have some Google Maps integration, something like that, you can actually call out to that JavaScript code from within C# and talk to your JavaScript libraries. You can do the opposite as well. So you can make calls into your C# code and execute methods and things from within JavaScript. And with .NET 6, what's really cool is anything that's been compiled to run in WebAssembly, you can also use those libraries with Blazor because it's operating with WebAssembly as well. So you can interop with existing libraries that were written in Rust or C++, for example. So you've got not only the JavaScript ecosystem, but you've got the WebAssembly ecosystem and the .NET ecosystem that you can tap for any kind of external third-party libraries you need. It's also very easy to create and publish component packages with Blazor as well. So I've mentioned WebAssembly a few times. I think it's probably best to give a little bit of primer as to what it is and how it works and why it's important to Blazor. So WebAssembly is a bytecode. It's a standard for the web, and it's a bytecode that the web understands. So it's a very low-level executable bytecode that we can use in our browsers. Now, Blazor comes with two modes of operation. I'll talk about how WebAssembly fits here first, and then we'll talk about something called server-side Blazor, which doesn't use WebAssembly, but it's kind of a different ballgame, but we'll compare those in a minute. Let's focus on the client first and foremost. In a normal application, when I say normal, I mean in a JavaScript world that we have been living in for quite some time now, we send the application JavaScript code. And the browser parses that code, compiles it, turns it into an abstract syntax tree, converts that into bytecode, and then finally does its operations with the browser. Where WebAssembly comes in is it gives us a path to that bytecode. So it is executable bytecode that we can use directly with the browser and skip that parser and compiler step because we're not sending it a text file. We're sending actual compiled code already. So we're able to parse and compile outside of the browser, and we can use other languages to do this. So we can use C++ and Rust and other low-level languages and compile those to things that execute within the browser. And these are the assemblies I said we can interop with directly. And the .NET framework is actually one of these compiled libraries. So what Microsoft did is they took WebAssembly and they compiled the .NET runtime to run in the browser. That used to be Mono, so you'll see Mono referenced here once in a while. It's actually a native .NET library now, or native .NET framework now. So it's actually the same full .NET framework that you get with a normal desktop Windows application and so on. So they've compiled WebAssembly or the .NET framework to run in the browser, and then Blazor sits atop that .NET runtime. So when we write our normal .NET DLL files, we can run those directly in the browser. And this means that things that you've written previous to Blazor, things that, business logic, for example, stuff that doesn't interact with UI or access disk, so normal just business logic behaviors, you can use those in Blazor even though you've written them before Blazor exists. So a really great example of this is I have a markdown parser that I like to use. It's called MarkDig. It's a NuGet package. It's been out for nearly 10 years now, something like that. It works natively with Blazor in the browser, no problem. There's also a mode of Blazor that you can use called server-side Blazor. And this is using the server to do everything. So you can put your Blazor application in the cloud and not have to worry about the WebAssembly portion of it, because it's actually going to run all of the code in the cloud. So what happens is you visit the website, you get a small JavaScript file that's sent to you. That establishes a Signal-R connection. This is a WebSocket that we can talk back and forth to our server application with. When there's an event on the browser, it sends that information back to the server. Server processes the changes that need to happen. For example, if I click on a button, it changes some state of the web page I'm looking at. It will send back only the state that has changed back to the browser. So if, say, an H1 tag changes, it doesn't repaint the entire page. It only gets that one bit of information back from the server and updates that element in the UI for us. So it's very fast and very efficient, but there are some pros and cons to these approaches. So let's compare them for a second. We have the client-side approach here. It's very low to no server overhead. You can host a WebAssembly Blazor application on GitHub pages. You don't have to have .NET installed on the server for it to work. It's RESTful, like many JavaScript applications. So we're going to use REST services to get data in and out of our application. It is offline and PWA compatible as well. So we can create progressive web apps with Blazor WebAssembly. The trade-offs here are it has a little bit larger payload because we are shipping the .NET runtime with our application. So on average, it's going to be about a meg of information that you're starting with. So you're gonna send down about a meg to your client plus whatever application logic that you write. It works in a disconnected environment. It's RESTful. You know, this is kind of the normal thing, but it's worth noting here because we're going to compare it with the server-side aspect of it. And then performance. The browser currently, or actually WebAssembly, the standard currently doesn't support just-in-time compilation. So Blazor runs in an interpreter mode. So this is a little bit less performant than we'd like it to be. And there are ways to get around this. There are performance tweaks that we can do to speed up our applications. Most applications won't hit any kind of real performance problems unless you're doing a lot of like real-time updates. Maybe you have a page that's showing thousands of records and they're all being updated in real time, like stock charts or something like that might be somewhat difficult here. But if you're just doing forms over data, normal web I/O type of things, there's not a whole lot you're going to have to worry about with performance. Server-side Blazor, however, a very tiny payload. Because everything's happening on the server, all you're getting is a couple K, I think it's like 3K worth of a JavaScript file, plus any HTML that's being transferred over to actually make the web page. So the payload here is minuscule. In some instances, you have very little abstraction here. Because you're not in a RESTful environment anymore, you're on the server already. So if your data is on that same server, you can write directly to like a DB context or something like that without having to put a REST service in between your application and its data. So if you have something that you need to go to market fast or you need to prototype very quickly, stand it up in server-side Blazor and just get it out there and get the prototype built, get the proof of concept done. It's a really fast and efficient way to write applications. Pre-rendering is also something that server-side Blazor does by default. It's the mode of operation for it. This is part of client-side Blazor as well as of .NET 5 and improved in .NET 6, which just shipped yesterday. So client-side can also do pre-rendering if you're running .NET on the server. So you can mitigate some of the long load times that might happen with that .NET being shipped down from the browser. The trade-offs here for server-side. A connection is always required. It's a WebSocket. So if you disconnect from Wi-Fi, for example, you're roaming with a mobile phone, that's going to interrupt your application. So you're going to have to reconnect and retry. So that can be not the best user experience. It's more server resource intensive, obviously, because you're doing all of the processing on the server versus letting WebAssembly on the client do work. So you are, in effect, responsible for any processing that's being done for all of your clients. So this is probably something you want to have in Azure, some kind of cloud hosting platform that with some scalability, because as your connections go up, you're going to want to scale those connections. Talk a little bit about the component ecosystem as well before I jump into some demos. So I work at Progress. We are the makers of Kendo UI and the Telerik UI components. So we make component libraries for pretty much all of the web ecosystem. So if it's Angular, React, jQuery, and everything that's ever been created for .NET, we have component libraries for these things. This slide's actually a bit old. We're up to 90 components now. And we have 3 base themes that can be turned into pretty much any look and feel that you want. So that's a little bit about what we do, and we have a Telerik component library for Blazor. So I'm going to show some demos here. I'll show some basic demos, how to create a quick app and work with the components, and then also show like a full featured app, what you can do and accomplish with Blazor. We'll wait for the projector to catch up here real quick. I want to make sure that you can all see my application. I'm going to use Visual Studio today, but you can use Visual Studio Code, your favorite text editor. All of those things work. You're going to get probably the best experience from Visual Studio because it's just, it's a Microsoft product and it's a Microsoft framework, so they integrate very well. But you can totally use Visual Studio Code and Rider and those type of things to build Blazor applications. It has a full suite of command line tools that work very well. But this is going to hold my hand very, very easily here in Visual Studio. I already have a project open, but I'll show you how we'd create one. So I'm going to click File, New Project. And Blazor is actually one of the templates in Visual Studio. From the command line, you'd run .NET New, and then say Blazor and the type of Blazor application you'd like to create. We'll go ahead and hit Next here. You just name your application, and then there are a few important things on the next screen that I want to talk about. So there's a couple sub-templates here. And the title of this talk is Full Stack .NET. So if you're going to do a full stack .NET application, you're going to want to check this box. So what this does is not only templates out your user interface part, your Blazor application, it will also template out an ASP.NET Server application. So you're going to get a server project, you're going to get a web project, and you're also going to get a shared library, which lets you share code between your server and your client. Again, they're both .NET, so any code that you write on the server is also technically usable on the client, depending on what the logic does. So if it's, one great example is like validation. Validation logic can be used on the server side to validate data that's going into a database. Those same validations might be useful in a form that you're collecting that data on the client. It's the same validation logic. If you've done any JavaScript development, you have to write your server-side validations and then turn around and write the same validations in JavaScript to do the same exact thing that you just wrote. In Blazor, you don't need to do that anymore. You can share that code between the client and the server. So I'm going to check this box and have a hosted application. You can also make this a progressive web app just by clicking that button. So if you're not familiar with progressive web apps, this means we can take our Blazor application and make it feel like it's an installed application on our devices. And this is really well supported on Windows and Android. It's somewhat supported on Safari or iOS. I don't think the Mac desktop supports it whatsoever. One of the really cool things that just got announced a couple weeks ago is you can install PWA applications to an Oculus. So this means you can be an Oculus developer. You can put your app in the Oculus store just by checking that box and creating an account with Oculus. So Blazor can do quite a few things. I'm going to back out of this, though. I already have one spun up. I don't want to waste any time redoing that work. This is a full stack Blazor application here. So you'll notice I've got 3 projects in my solution. I've got a client project, a server project, and a shared project. The client is the WebAssembly Blazor application. We'll take a look at that. We have our www root folder. This is where all of our static resources go. Images, CSS files, any JavaScript we want to interop with goes in this folder. We also have a couple pages that have been added to the project as well. I'll show you what those demo pages look like in just a moment. We also have a shared folder here. These are shared components that kind of make up the shell of our application. We have things like our main layout. If you're familiar with web forms, these are similar to your master pages, but they're any type of layout that you want to share with your application would normally go in here. And then we have a nav menu component that drives the navigation for our application. In the server project, this is a standard ASP.NET application here. So we have controllers, and then we have pages. So the pages might sound a little odd because we have a client-side framework already. Pages in this context are just going to be an error page, but if you're doing pre-rendering, you may have a bootstrapping file here as well, so you can pre-render the Blazor application or the Blazor pages and then send those pre-rendered to your client. Controllers, these are standard web API controllers. So you'll see I have a weather forecast controller here. This one just generates some random data that we can use on our client, but essentially here you'd have web APIs that are backed by maybe like a SQL server, GraphQL, any of those type of things, and then provide endpoints for your client application to consume. Sure. Yes, absolutely. So these are just standard web APIs, so they spit out JSON responses. So the question was, if you didn't hear it, can we consume this from another application? Absolutely. You could have a Xamarin app or just a Swift iOS application. Anything that can consume REST can call this endpoint. It's just standard .NET Web API. And I can probably show you an example of that as well. We'll dive into the shared real quick here too. So since we're using C# on the front and back end, we can share our weather forecast class. So serialization is absolutely simple in Blazor app, because on the server side, we're going to tell our controller that we're going to send some weather forecast data to our client, and on the client, we're going to consume a weather forecast object. We don't have to do any kind of weird mapping between C# and .NET, or sorry, C# and JavaScript. It understands these things on the client and the server. So deserializing and serializing the JSON between the server and the client is absolutely simple, and I'll show you that as well. So let's take it and run the application. I'm going to run without debugging because I'm on my laptop and it doesn't quite have the horsepower to do this efficiently. So we'll run without debugging here. You can see what the Hello World project looks like. We have a counter component. It's very, very simple stuff just to show you how the framework operates. So we can click the counter and it increments the count here. We'll dive into the code in just a sec. I also have a weather display here. That's taking the weather from our web API call and just displaying it in an HTML table here. And real quick, if I can maybe possibly get this to work, we should be able to hit the API. Let me see if I can find the controller. weather forecast controller and see exactly what this is called. So this should be weather forecast, and that should be good enough. There we go. So if I call the controller directly without going through the UI, I actually just get the JSON response back, and that is an example of the question you asked earlier. Can I consume this from other applications? Absolutely, it's just a JSON response. Anything that can use JSON can use the server project. ASP.NET, by the way, comes with OpenAPI or Swagger by default. If you've ever seen or used that before, it's really cool. It's an explorer that comes up, and it's a UI where you can go explore all of the responses that your server project can give. So you can hit all your endpoints and test them right in the browser. It's like an interactive, like API REPL. So on the client side, we've got our counter component. So we'll take a look at that real quick. One thing that it makes Blazor really productive is this component framework that it has. So in this page, we have our routing. So unlike something like Angular, where all the routing is in a single file somewhere, the routing is actually decorated on the components themselves. So this component is routable. So the counter component, it is a component, but it also has a route. So again, everything in Blazor is component-based. So when I visit /counter, I actually visit that component and render it in the browser. We have some normal markup here in this section. And we're using Razor, the Razor syntax, to do our data binding here. So we have some one-way data binding. We also have two-way data binding that we can use. So we're binding to the current count and the onClick event. And these just correlate to the code that's in the block below. And much like other .NET frameworks that you may have worked with, you can have code behind files as well. So you don't have to have your code intermingled here. You can actually put it in a CS file and access it that way too. So you can separate those. General rule of thumb for me is if my markup or my code takes up a full screen, I'll split those out into separate files so I can work on them independently. So what's happening here is I've bound to my increment count, and I have an increment count method here. Again, this is all C# and .NET, no JavaScript here. When I click this button, I'm going to increment the field current count, and then current count is bound up here as well, so my count gets incremented live in the browser, no JavaScript required. Similarly, this is how my fetch data page works. So I have my fetch data route. So the example that's grabbing the weather forecast, I can route to it. I'm using that shared library that's here in my application because I have some weather forecasts that I'm using. And I also have an inject statement here. So @inject is essentially telling the application, this component wants to inject a service. Go ahead and get me an HTTP client service and call it HTTP. And I can inject any sort of service that I want here. This is actually how we do state management as well. State management is really simple in Blazor. It's just a plain old class object, a POCO object, and we can stash things in it through dependency injection and access those properties and methods. So any type of class or service can be injected here very easily. So I'm going to take HTTP client, and down in my code, when the application, or sorry, when the component initializes, it has several lifecycle methods. One of the most common ones is oninitialized async. When my application or my component initializes, I'm going to call an HTTP request, get from JSON async, and I'm going to expect back an array of weather forecasts. We saw that JSON in the browser just a few minutes ago. That's what I'm going to get back. And because I'm using the type, the strong type here of weather forecast, the HTTP client knows I want to deserialize or serialize that into a class, that JSON into a class. That's the only code I need to write to do that. So that serialization happens just by default. We're going to await that and put that into our weather forecast array, and then back up in our component code here. If we don't have any weather forecasts, we're going to show a loading message. There's a lot of ways that you can incorporate these loading messages and do spinners and all sorts of fancy stuff. This is a very basic example, but we're going to go ahead and show a loading message if we don't have data. If we do have data, and again, these are just Razor syntax here. So I've got an if statement. I'm going to say else, and then I will render out my table. And for each of the elements that is in that forecast array, I'm going to write those out using the Razor syntax. What's nice here is I have full IntelliSense here. So if you've ever done .NET development, especially within Visual Studio, this podium is going to make my mouse keep sliding. There we go. So it's trying to come up here. It might be a little hard to see on the screen there, but we essentially get a list of properties that are available from that object. And these are actual properties. This is a little bit different than autocomplete is in JavaScript or Visual Studio Code. This is IntelliSense, so this is a strong type. And the compiler knows what properties and methods are available on those objects, and it displays those in a list for us so we can quickly type those things out with confidence that we're not going to misspell something and throw some errors. And if we did misspell something, we do have a compiler that is going to catch that error and display a red underscore in there immediately, letting us know that's not a real thing. Again, we're working with .NET, not JavaScript. So that dynamic stuff can be nice. It can also bite you very quickly, as you know if you've done JavaScript before. Don't have that problem here. You've got a compiler working with you. We can format these however we'd like. You see we're doing some short date string here and things like that. And that is all that it takes to create that page. That is our weather forecast page that we saw running in the browser just a second ago. That's this one here. We also have hot reload. I'm going to try this. Let's see if this works here. I was having some issues with it earlier because there, again, was an update yesterday and I haven't fully updated my machine yet. That is in the wrong place. We're in Atlanta. We'll say Atlanta weather there. And you'll notice that my browser's already updated that H1 tag with the new information. If you didn't catch that, and we can do it in real time, we'll throw a couple numbers on the end here. And when I save, we're automatically updating that. May sound a little insignificant if you come from JavaScript. JavaScript's really good at doing that. In .NET, we're working with a compiler and compiled languages. So this is a pretty big engineering feat. So that's really special to have that available in .NET 6 now. So we've got hot reload. I'm going to go on to, actually let me take questions first and then I'll show a more advanced sample because we have about 20 minutes and there's a lot of things that we can cover. Yes?
You showed a slide earlier that showed like client pros and cons and server pros and cons or whatever. Mm-hmm. When you said client, did you mean some client part of Blazor or you mean like client frameworks like?
No, Blazor specifically. So Blazor specifically in that context, it's not quite as fast as a JavaScript framework would be. The Hello World demo is going to be a little bit bigger than what you might see in a JavaScript framework. The thing that I've seen with the comparison there is your applications in Blazor start a little large, but they don't grow very much. Your UI code and things, they don't compile to anything really meaningful. If you're working with Angular or React, the more JavaScript you write, the bigger those applications tend to get. I think your end game is going to be about the same as far as the size of those applications. So it's kind of giving a comparison between client-side Blazor with WebAssembly and server-side Blazor with SignalR.
Okay. And two things you said that really perked up my ears. Mm-hmm. You said this is maintaining a constant socket connection between the client and server?
Server-side Blazor. So when you're not using WebAssembly, it's using a WebSocket. If you're using WebAssembly, you can forget about that.
Were you using WebAssembly in that example?
Yes, I was using WebAssembly in the example I gave.
And when you click that button earlier, you said something about it sending that information to the server.
Yes. No. Sorry if I made that confusing. So this HTTP client, when our component loads, it requests with an HTTP request a normal RESTful connection. So
earlier you had a count button when you were clicking it and it was incrementing. Is that going to the server for that?
No, that's being processed locally through WebAssembly. Yep.
Determined in this whether we were doing WebAssembly? Oh, was that the checkboxes when you created the project?
Yes. Sorry. The whole demo that I just did is all WebAssembly. Yes.
I'm curious, what is, at least in this example, what, if anything, is going back and forth through the WebSocket?
So I don't have any WebSockets in this demo. This is all client-side.
They're like, in case you do need a WebSocket.
Yeah, so there's two different ways to host Blazor. Let's go back again here. It's a one or the other. One or the other type of thing here. I can use WebAssembly, do everything on the client, and communicate with any backend. In this case, I had a .NET backend, so any communication that I did was easily serialized and everything on that server side. If I want to run completely server side, I can, and that is going to use SignalR and WebSockets. So these are two completely separate things, and I can pick the one that I want that fits best for me. The trade-offs there are going to be, again, server processing very fast. Like I can move extremely quick, do really heavy processing, and the client's never going to notice. But if they get disconnected, then they're going to have a problem with the app. WebAssembly, I'm not going to do as processor-intensive things on my client. But if they happen to lose Wi-Fi for a minute or something, they're not going to have any real noticeable interruption unless they're trying to get data for something. Yes?
Is that easy to change after you've created the project, say 2 years down the road, and you feel like you picked the wrong direction?
Yes, it's an excellent question. So the code that you write, 99% of it is going to be identical between these two models. The thing that changes is how you get your data. So if you write an interface that abstracts away how the data is retrieved, you can just implement the interface and switch between the two. You can almost do it in real time. There's been some demos that people have done where it actually flips in real time through like a flag that you can set. So you can use both hosting models at once. It's that interchangeable. You could get away with something like that if you wanted to engineer it. But the client code is exactly the same. Yes, you've been holding your hand up for a bit there.
So from the server-side perspective and from a DOM rendering perspective, you click a button on the DOM and then it sends delta to the server processes it, and then does it send something back to the client to actually change the DOM?
Okay, so it depends on which one of these two you're using. Sorry for the confusion there. The client-side Blazor, if the processing is done and it doesn't require server resources, it's all done on the browser. So if you're calculating something, clicking that counter button and it's incrementing the count, server's never being touched. On server-side Blazor, literally everything you do is calculated by the server. Just the information that it needs to update the UI is all that is ever sent. So if I ran that same counter example in server-side Blazor, when I click on the count button, the server gets the message, the count button was clicked. The application goes, the number 3 changed to 4, and it sends back the DOM diff. So it'll have the paragraph with the number 4 in it. It sends that down and tells the browser where to render it, and then that's updated. Okay. Yes.
So why would you ever want to pick the server side? That seems so foreign to what...
It's a great question again. Server-side Blazor is really cool if you want to build something very rapidly and not have to write a web service. So I can actually, here's a good example of it. If I did this in server-side Blazor on the fetch data page, instead of using a REST call here, I can actually just call my database. I could say dbcontext.weather, get this from the weather database, and not have to write any intermediate code, not have to do any like data transformation objects, any of that stuff. It's not a fit for everybody, but if you, for example, and this is where I came from, I worked in factories and I wrote kiosk software for factories. So we'd have a big machine and a giant display over the top of it, and that display is never going to move. It's never going to be disconnected. It's always got a constant connection to the server. So I can write this and drop a whole layer out of my web stack. So I don't have a front end and a back end and anything else. I just have one solution with one project in it, and all of my code is there, and it all runs on the same server. That kiosk is never going to move, and I can do real-time updates to it nonstop. So it's excellent for stuff like that. For your like average consumer thing, maybe like an Uber app or like, something like that, where especially if you might get differing Wi-Fi like 3G, 4G connections and may drop, don't want to use server for that. You want to use the WebAssembly. Yes, in the back.
Just had a quick question on your on-click event. Would you pass parameters if you needed them, or would you actually just set properties and read them from your code section?
Okay, so both of those things work. So the question is about the on-click event. So if I wanted to pass additional information here, I can actually open up, I could use a delegate, or I can actually just open up here and do an inline anonymous function. So I could call a method like increment count here and pass in like an integer, for example. So I could say like increment count 9 or something, and I could accept that here. Oops. So I could use it in my method, and compiler, I've done something to make it angry. I think I'm missing parentheses on the end. Yeah. So I could delegate off like that. This is handy if you're doing loops over things and you want the button click to pass in like something from a template. There's additional data I want to pass, like there's a for each loop here. I want to pass in the current item I'm iterating over. So maybe when I click the button, I get the instance of that item that was being iterated on when that button was rendered. So that's very common to do that. It's a great question. Actually, if I go in, I can show probably some more advanced demos here. So you guys are really on top of the questions. I love it. I love when people ask questions. If I go through an entire talk, nobody says a peep at the end, I can't tell if I did like an amazing job that you don't even have a question to ask, or if nobody was paying attention. So I love the questions. Keep them coming. I have an app. This has some of our Telerik UI components in it, so you'll see some of those as well. I'm a huge fan of our stuff, not because I work there, but because I was a customer for 6 years before I started working here. So I used the Telerik UI for web forms, which is Telerik Ajax, and I also used our MVC products as well before joining the company 6 years ago. And I got to help push the Blazor stuff and create the product with the team. So this is called Blazing Coffee Warehouse. This is a fully baked like kitchen sink app. If it does look not performant, it's because my laptop is really having a problem today. I have a new one on order and I'm waiting for it to show up. So don't let that dictate like how you think the apps perform. They're not this slow. It's my laptop just being a pain. So this is a component that it's called a tile layout component. So we can lay our elements out, and then our users can actually drag and drop these components, and they will remain in those places. So there's a quick API call that we do here, and I can show the code for this as well. It's really just a one-liner, and it says when the state has changed on this tile layout, go ahead and get the state and stash it somewhere. That could be a SQL server, local storage in the case that we're using here. So we're just taking the state of that component and throwing it in local storage, so when the user comes back to this page, the elements are still in the place they left them. So it's really easy to do. It's only like 2 lines of code, one saving it and one loading it. So this is just an easy like drag and drop menu that we can create with these components. If we go into sales, and notice the browser is telling me I can install this as a PWA as well. So I can click this button and hit install. The Chrome for the application is going to drop away. So our browser just disappeared around us. And down at the bottom, we have our preview, our little Windows preview. And we actually get an icon on the desktop that we can move wherever we'd like and pin it and all that good stuff. This is showing a synchronization between a chart and a data grid. So we can actually take this date picker, and this is a date range picker, so we can select the start and end dates here. So we could change the date range, and it's going to sync up with both of those views. So our data stays in sync there. What's really cool about this page, and again, this is WebAssembly Blazor, so not the SignalR stuff. The UI is being processed on the client, and then when I click that button, it triggers an event that says, go ahead and fetch some new data for this data grid. The state of that data grid is then taken and sent to the server. And we make an HTTP request out to the server with the state of the grid. And if the state of the grid is sent to the server gets it and goes, okay, I know what the state means. We're going to send that to Entity Framework. And Entity Framework looks at it and goes, okay, you're on page 1. We're showing 10 records. These are the filtering options, yada, yada, yada. And it queries the database with only the data that's going to be displayed in the browser. So I'm only going to grab 10 records here. I'm not going to grab, it says 2,924 records total in that data set. I'm not grabbing all of that. I'm just grabbing 10 records and then sending those back down to the client. So this is very fast and efficient, not only on the client, but on the server as well, because it's only querying the database for what it needs. This is an example of one of our data grids that it shows off some of the templating features. Templating is something that's really easy to do with the component model in Blazor. So we open up a template here, and we can drop in images, other components, do some coloring, stuff like that within that template on each row here. So it's very easy to template things. Doing CRUD operations, create, read, update, delete, all of that is very simple as well. Not just with our components, but with Blazor, this is generally a pretty easy thing to do. In this example, we can add a new product. We get a nice pop-up here. We can add that product. We can edit an existing product. I can hit update, and you'll see I get a success message up in the top corner. We can toggle rows very easily, all of those things, delete records with confirmation, all of that sort of stuff. So this kind of gives you the idea of what can be built with Blazor and our components. This is a full line of business application. These aren't hobby projects that you can build. You can actually build real scalable things with Blazor. You got a question?
Yeah. Going back to server side versus client side, is there any way you can fine tune? Okay, say I start off with a server side app, and then I say I want one page that does client side rendering. Do you have that?
That's not something that's out of the box. What you can do if let's see. The best thing you could probably do is you can do server-side rendering with client-side. The way that works is the server will render the initial page, and it'll send that whole HTML down so you don't have like loading screens and things. If it has data associated with it, for example, let's see here. If I had a page like this, it's going to want to render the entire page with the data in it. It will send that down. There are instances where you may do updates after that. So what you want to do, and this exists in .NET 6 only, so you want to be on the latest version, it will send down what, it's very similar to the view state. So don't get scared by that. If you don't know what view state is, like a web forms thing, it got really like bloated and out of control. It's similar to view state, but without all the problems that view state had. So it basically has enough information in it to let the web application know what the state of that component was in when it was rendered from the server. So the client side can pick up and do any updates without having to like reload the entire component again. So that type of pre-rendering exists in .NET 6 now. It's a real performance increase. So you can mix and match a little bit, but for the hosting part of it, you kind of pick one or the other. Yes?
Can you go into the client-side routing a little bit more? And
Oh, absolutely.
What would need, so like in your server project, why do you need an error page there instead of making a client error page? I think when you spun it up, you still had like the pages inside your...
Yeah, so let me see if I can answer that. We had one more over there too. I didn't want to...
Yeah, I'm just curious, you said that the .NET runtime gets downloaded with it. Is that something that gets cached? Is that something that's pulled from the CDN, or is that just part of the build process that just get a massive package?
So it is indeed cached. I think the reason they're not using CDNs for that is because of the tree shaking that happens, the assembly trimming. So if you're not using the full framework and you're only using pieces of it, you're not going to get the entire framework every time. So if you visited one person's Blazor app and then another, you might have different bits there. But yes, it does get cached, so you don't have to have that hit every time. Let me see if I can answer that other question as well. The routing part, the client-side routing, it's done at the page level. We can look at this page here. So on this page, we have a page directive that says this component is routable from manage employees. If we wanted to pass information here, we could either pass it through a query string, or we could actually put a route constraint on it. So we could say something like ID here, and if we wanted that to be an integer, we could do it like that. So we could pass data into this as well. This is good for like parent-child views, where you have like a page that has menu or something, and you click on it, and you want to see the details of that product. You can pass like an ID across easily like that. Is there anything more specific with the routing that you wanted to see?
So like currently, I'm pointing like an attribute route on the controller to an index CSHTML that runs React client-side routing. So I guess like trying to keep this apart from that. Does that make sense?
Yeah, so I can't remember which direction the routes are resolved in. I can take you through like the boot cycle of the application. That might help a little bit. Before I do that, you had a question again in the front?
The page directive, is that required? Because that kind of restricts where you can get to this component from.
The page directive is required if you want to route to that component. You can overload them as well, so you can have multiple in here. So if I wanted this to be, yeah, if I wanted, if I knew people might accidentally just type employees there, I could have both routes route to that directive. I could have none and then consume the component in another page. And even if it has a route directive, I can still use the component in another page, which is kind of not common, but it's it's still a component, so I can just put it anywhere I like. So I can hit it from a route, or I can embed it in another page. The way these applications boot up, so you're going to hit your server first. The server side, if you're doing server-side rendering, there will be a CSHTML page in there that is going to handle the server rendering. I don't think, I do have a layout in here. So you're going to hit this layout CSHTML page first, and then the Blazor application gets rendered in the render body section of that HTML there. If I don't have pre-rendering, the server will then send down the index HTML page from the client. I don't know if I still have, yeah, there's one in here. So it's going to send down this index HTML file instead of the CSHTML file. And then this one, you have a similar section that is the container for the application. So this one is going to be app, which I think this is still the .NET 5 version. It's now div ID app or something like that now. They changed it in the last version. But essentially, it's just like Angular React. There's a tag in which your application runs inside of. Once it is loaded in there, the client-side routing takes over. If you hit a route, though, that doesn't exist on the client, it will then default back to the server. And then if the server doesn't have it, then you get an error. Now, depending on who kicked off the routing, you're either going to get that error CSHTML, or you're going to get an error inside the Blazor window that'll just say route not found or something like that. So it just depends on exactly how that route got hit. So you saw earlier when I ran the other example, let me see if I can get it to work on this one. I visited the Web API endpoint directly. So it skipped over, or it saw that there was no client route for that. And then it went to the server and asked it. And it's like, yeah, I have a Web API endpoint, and it spit out the JSON. So hopefully that helps. And I don't know if I have Swagger enabled on this one. We could try that. Either way, this will be a useful example. So this one hit the server without the client-side routing because I typed it in directly, and the server's like, we don't have a route for this.
So if you have like employee/ID in the client and employee/ID, maybe it comes back and it still follow back?
One of them would take over. I can't remember which. You would not be able to access both.
Well, I guess in that case, you could call your employees from backend one from HTTP anyways.
Yeah, you'd probably want to put them in some kind of like a hierarchy, like API/employees versus just both naming them both the same, because you're gonna get where one overrides the other. Let's take a look here too. Oh, actually, I think we're over time here. I'm happy to answer more questions. I think there's no other speakers coming, so if anybody wants more questions, let me know. For those that did answer question, Meryl, can you hand out some swag? We had this gentleman in the front, in the back, and these two in the middle here. I think one left on that side already. But we had some extra things to give away. We've got some gift cards and drinks.